Once upon a time, there's a military strategist called Han Xin, and one day a messenger came to him.
Mr. Han, an army of 500 soldiers is at close range. What are we going to do?
Han Xin, being a skilled mathematician now, says,
Well, how about we figure out the number of soldiers we have first, and then we can evaluate the situation accordingly, yeah, would you say? Well, we have around 1,000 soldiers. But that's not accurate enough, bro. I need to know the actual number.
He then went out to his army and gave the following instructions.
Group yourselves together in threes.
They did, and one guy was left over.
Group yourselves together in fives.
They did, and this time, two guys were left over.
Now group yourselves together in sevens.
They did, and guess what? 3 soldiers were left over this time. Han Xin looked at that, did some math, and proclaimed,
Well, okay, people, we have an army of 500 soldiers coming at us, and we have exactly 997 soldiers amongst us. That, to me, is a pretty significant difference. So, let's get rolling, bros.
The soldiers were impressed and inspired by their commander's mathematical talents and went on defeating the enemy army with ease. So, how did Han do that? Well, the soldiers' groupings can be summed down to a system of congruences where we define two integers a and b to be congruent modulo m if a and b give the same remainder when divided by m. If we say that the number of soldiers in Han's army is x, then we know that x is congruent to 1 mod 3, 2 mod 5, and 3 mod 7. We can sum these up into a system of simultaneous linear congruences, kind of similar to your simultaneous equations, and solve it using the Chinese Remainder Theorem. CRT states that if you have pairwise relatively prime positive integers m1 through mr, which means that no two integers out of that list share any common factor except for 1. Then the following system of congruences will have a unique solution modulo big M, where big M equals to the product of m1 through to mr. More importantly, the solution is as follows, where the particular nk is big M divided by the particular smaller case mk, and the individual xi's are the solutions of the congruence relations ni xi is congruent to 1 modulo mi. Putting that in the context of the problem, we have 3 congruence relations. We need to then solve for x1, x2, and x3. You can solve these by doing a simple naive search, which basically means plugging in numbers and see which one works. And if you do that, you can see that the first x1 for the relation to be true is 2, which means x1 is congruent to 2 mod 3. Similarly, we get x2 is congruent to 1 mod 5, and x3 is congruent to 1 mod 7. Lastly, all we need to do is plug those numbers into the equations and find that x is congruent to 52 mod 105. This means that x can be any number that gives a remainder of 52 while divided by 105, which means that x can be any number out of this list. Now, since Han already knows that he has around 1,000 soldiers, he can figure it out that he has exactly 997 soldiers, so good job, Han.